Now that we've discussed the idea of the area of a polar region using this formula, we're going to apply it to an actual example. So what we want to do is we want to find the integral of the shaded region here. And we know that the function is r equals 2 cosine theta. So if I were going to label this graph, what I would do is I would say, okay, this goes all the way out to 2, and then the center is at 1, 0, and that's kind of how I do it. Now the key here is, just like you're doing any kind of area of a shaded region problem, you have to find the bounds. That's always one of the most difficult things. So we have to ask ourselves, well, what are the bounds of this? Well, when theta is equal to 0, for instance, maybe it's easier to make a chart. When theta is 0, well, cosine of 0 is 1. So that tells me r is 2. And by the time theta gets up to like pi over 4, cosine of pi over 4 is square root of 2 divided by 2. So this is just going to be square root of 2. By the time it gets up to pi over 3, for instance, cosine of pi over 3 is 1/2. So this is down to 1. By the time I get to pi over 2, the cosine of pi over 2 is 0. So again, we normally always start at that zero angle, that positive x-axis, and then we raise the angle slowly and go. Now what I notice is after I go towards 0, if I went to like 2 pi over 3, what I remember is that, or what I see is that r becomes -1. Well, for this theorem to work, or for using this formula, the function has to be non-negative. It can't be negative. So that means that we go up to 0 and stop at 1/2. That's kind of how we determine that. We go up. By the time we get to 1/2, we're actually standing straight up. See, we're going up. This would be pi over 4, pi over 3, pi over 2. We're pointed straight up. There's actually no arrow straight up there because it's actually 0, because we stopped at the edge there. And that's the idea. This would be the theta is 0, theta is pi over 4, theta is pi over 3, theta is pi over 2. So that's how that goes up, and then kind of shrinks down. Notice as we keep going here, if I were to draw lines, they would be shrinking down to 0. So there's a lot going on here. Now what we want to do is just say, okay, well, it looks like this is my starting angle, and that looks like it's my ending angle. So alpha to beta. The way we want to do this now is just to set it up. We say our area is 1/2 from 0 to pi over 2. And r is a function of theta, so I would then say 2 cosine theta squared d theta. Okay, simple enough. Now what we can do is we can finish out this problem. We're going to get that that's 1/2 integral from 0 to pi over 2, 4 cosine squared theta d theta. Now what you may remember, I hope you remember from some of the previous sections we've done, is that when we had to integrate something like cosine squared of theta, we would have to use an angle transform, or one of the identities. Remember that cosine squared theta is 1 plus cosine of 2 theta over 2. So in that particular case, we can use that substitution here and say, well, this 1/2 here technically turns that into 2. So I absorb that here, and then I'm going to cancel it with that 2 over there, and I'm going to get the integral from 0 to pi over 2 of 1 plus cosine 2 theta d theta, which then, when I take the antiderivative, is going to be theta plus 1/2 sine of 2 theta from 0 to pi over 2, at which point I substitute in for the integral. I say that's pi over 2 plus 1/2 sine of pi minus 0 plus 1/2 sine of 0. Now what we know is sine of 0 is 0, so this whole thing goes away. What we know is that sine of pi is also 0, that goes away. leaving us a final answer, pi over 2. I'm thinking about this for a second. I apologize. Because this doesn't seem correct. It is. I'm so sorry. So I asked myself a question. Is this right? How do I know this is right? Well, think about this. This is pretty simple. This is a circle of radius 1. Right? This is a circle of radius 1, so the radius is 1, which means the area of the circle is pi r squared, or just pi. But we're looking for the shaded region, which is half of that, which is pi over 2. So I apologize for that little momentary lapse there. I just wanted to make sure that we did get the right answer. It's always important to check answers when you can.